Hello students, in this particular lecture we will be solving some few more questions, and in this particular video I had bought some conceptual question which has been asked based on the application of class 11th and 12th physics that has been asked in ATC 2021. The very first question, this was easy, this was like there is nothing, it's just a 5-second question. Let us see it first. Which of the following statement is incorrect for heat? For heat, okay. Heat content of body depends upon its mass, temperature, and nature. So mass spelling was wrong, but you can understand. So yes, even we had studied MC delta T. Okay, so this is mass. This is the heat capacity, specific heat capacity. This is the property or nature. Okay, you can simply say that it is nothing. It is the nature of that body. Okay, and this is the temperature difference. So of course, it depends. It is correct. It is measured by the principle of calorimetry. Yes, we had even studied various method by which we had calculated the heat transfer by the use of calorimetry. Okay. Further, third point, the temperature of the two bodies are same even if their heat contents are different. If their heat contents will be different, it is not necessary that the temperature of both the bodies are same. It is not necessary. It can be possible in certain case. See, if the specific heat is manipulated accordingly, then this is possible, but not true always. This is not true always. Okay, so that's why this option is wrong. Let us see the fourth option also. When two bodies are mixed, the total heat is equal to sum of the heat contents of the two bodies. See, heat is what? Heat is simply energy. Okay, and energy cannot be created nor be destroyed. The total heat, they are asking about the total heat. So total heat will be simply the summation of the heat contents of both the bodies. Okay, so it was again a very correct statement. So that's why the only incorrect statement will be option number C, which we can directly conclude that it is wrong. Okay, next question. This is again a good quality of question, but if suppose some BTech students are there, then there can be a possibility that this question may be like very simple for them. But still, I will be telling you the whole concept, though I had discussed such concepts by default in your video lectures. And this concept has been directly asked from the part which I had taught you in the video lecture. Okay. The hydraulic lift is used to raise a car of mass 2000 kg. The area of cross section of piston on which car is placed is 375 centimeter square. What pressure the smaller piston has to bear if the bigger piston is 2 meter higher than the smaller piston? The bigger piston is 2 meter higher than the smaller piston. That means wherever the car is placed, okay, like I'm first of all, like let me draw my dream car. Okay, I don't know whether it will look good or what, I don't know. Okay, like suppose this is a car, very bad drawing, I know. This is you and this is your soulmate sitting together, both hands are joined, and now this car is actually kept on a piston. This is kept on a piston. So suppose this piston is there, okay, and this piston is having area as mentioned as 375 centimeter square, and very important, the weight, the mass has been given as 2000 kgs, and the value you have to consider. So overall, when you will be drawing the free body diagram, by default the net force implied by this particular car will be, force will be, that means it is weight, weight is nothing, it will be 2000, and g value they had told you as 9.8 you have to consider. So 9.8 into 2, it will be 19.6, and this will be 3 zeros, so that will be nothing, it will be 19.6 or 19600. Okay, so this much Newton it will be there. And because this is actually a piston, this is actually a piston you can consider. Okay, like suppose this is a 3D piston. Okay, and it is placed somewhere else. Okay, and everywhere you might be knowing, everywhere water will be there. Everywhere I should draw the drawing so that you can at least able to visualize the thing. Is it's all about the game of visualization. If you are able to visualize, then it's nothing is like tough or difficult, you can say. Okay, suppose this is everywhere the oil is there, and the property of oil which they had mentioned, it is the density of this oil, it is 800 kg per meter cube. And the very important thing is they had mentioned that the difference between the height of this bigger piston and smaller piston, suppose somewhere else here the smaller piston is there, suppose it is in this look. Okay, suppose this is the smaller piston. Okay, and the difference between the height is nothing, it is 2 meters. So what you can, they had simply asked you that the what is the pressure on the smaller piston, or what should be the pressure that this piston has to bear. So simply let me know first of all, simply you should let me know that whether the pressure at this piston will be larger or bigger. I had taught you the fluid mechanics part also. So from there you can directly answer this particular question. It's very easy. Okay, everywhere it is like water, you can simply show it. So simply let me know. See, it is everywhere that these pistons are actually immersed in oil. Okay. So by simply Pascal's law, you know that everywhere the pressure will be same, but the only condition is they should be on the same level. The liquid should not change, and if the levels are same, then the pressure will also be same. But because there is a difference of height, then by default this will create a pressure difference of rho g delta h. Delta h is nothing, this is 2 meters. So the difference between this level and this level will be rho g delta h. So if you are knowing the pressure at this particular end, then you can simply add, because you are going downward. When you go downward, the pressure increases. The pressure actually increases. So that's why it is as simple as that. I am simply like showing it you, like this is suppose pressure at point A and this is pressure at point B. So the equation is as simple as PA plus this rho g delta H. When you add this much pressure, you will come to this particular point, and by default you will be able to calculate the pressure at B. That's it. It is as simple as that. And sir, this rho gh, which density we have to consider? There can be a possibility that they can even mention you the density of the piston just to confuse you. But this rho gh, this is inside the fluid. This pressure difference is created because of this fluid. So that's why this density is actually the density of fluid. Okay, so pressure PA will be calculated as, sir, PA is nothing, it is force upon area, and force upon area, total force, it is 19600 divided by 375 into centimeter square. So you can change that in meter square, so this will become meter square and this will be simply in newtons. Okay, so this will become Pascal. So this term should also be in Pascal. See, even in the numerical, in the video lecture, I had told you that if you are putting this in kilonewton, okay, or kilopascal, then this term should also be kilopascal. Apple can be only added to apple. You cannot add a mango into the apple and you can obtain guava. It is not possible. Always apple will be added to an apple and the final result will also be an apple. So if this is in Newton, this should also be in Newton, and the final result will also be in Newton. Okay, so rho gh, so we will be putting it directly. Sir, if we have to convert that in kilopascal, we will directly write in the format of specific density that you already know. I had even told you all the tricks and tips in the video lectures. So by default, this rho density we have to consider as 800. Rho g we have to consider 9.8 into delta h, it is 2, and this will be nothing, this will be simply giving you PB. And when you will be calculating this PB, this will be nothing, this will be somewhere around 5.2 into 10 to the power 5. Okay, and when you will be adding this will become 5.38. 5.38 into 10 to the power 5 Newton per meter square, which is close to this option number A. So this question was as simple as that. The only thing which actually strike the mind of the students in examination is that this question is bigger and it is involving a very large calculation. That's why it will be taking much time. But if you are having a good practice, then by default I can tell you this can be very easily done, and just on the name of concept you have to apply this formula. And even I had made you practice for such situations, I think in more than 10 problems. Only in the video lecture I had told you these concepts, even not only with respect to this, even with respect to surface tension also I had told you. So I hope you might got these particular things. Okay, now next question. Again, this question is again really good, and I can tell you this question I had given in the assignment problems last year. Even they had not changed the data, I had given the same data last time in the assignment and the same problem, even with the options, the same options had even appeared. Okay, so let us solve this problem again. Last time we had solved for the Laksh batch. This time also I am solving this on YouTube just because it has appeared on the previous year. So let us first see locus of point on this plane where the potential has a zero value. Okay, so you have to calculate potential. Okay, you have to simply calculate the locus of such point where the potential becomes zero, and the condition they had given, the two charges are q and minus 2q, are placed at a distance of 6 meter apart on a horizontal plane. In the video lecture I had already told you, whenever you are finding the locus of any such point whose potential is zero, by default the locus is a circle. So this theory I had told you, but in the examination in all the four options they had given the circle. So that's why of course you have to make some calculation. Now in video lecture even I had told you that they can give you different locus, so you can eliminate the options, but in this question they had not even given you any other locus. So I know that it will be circle. So for any circle, when you define its radius or center, it is in actually in the format of x minus h whole square plus y minus k whole square is equal to r square, where the center is simply defined by h comma k, and the radius will be defined by smaller. This we had already studied. So we have to somehow approach this format from the given condition. Right? Now, how exactly we will be approaching this? First of all, let us define some point where actually the potential becomes zero. And even I last time I had done few problems related to if both the charges are positive, then where the potential zero potential point will lie. Right now both the charges are different or of equal, sorry, unequal sign, so that's why the zero potential point, it will lie in between the charges. Okay, so directly I am considering, suppose this is origin, so this is having 0 comma 0, and both the charges are actually separated by 6 meters. Okay, so suppose this is charge q and this is charge minus 2q. Okay, and suppose any point is there, suppose this is point p, and it is having suppose x comma y. Okay, because we had represented in the same format, so suppose the locus, okay, the coordinates we had considered x and y only. Okay, now one extra thing which you have to consider, if this is x, then by default this height from this origin, this will be y, and this particular distance, okay, from origin, this will become x, then this will become 6 minus x, because the total, it was 6 meters. Okay, so when you will be calculating the distance, this will be suppose r1, and this will be suppose r2. the distance of zero potential point from both the charges. Okay, so this will be R1 from charge Q and this will be R2 from charge minus 2Q. Right? Now, what is the value of potential? Sir, we know it was very easy. The potential is given by KQ by R. Right? So for charge Q1, it will be R1, and when we are calculating the potential because of the second charge, it will be nothing, it will be kq2 upon r2. The another thing is, it's another thing that q1, it is q, so kq upon this is r1 and this is k. The q2 is minus 2q, this is minus 2q divided by r2, because the net potential, even I had told you that the electric potential is a scalar quantity, so there will not be any vector addition, you can directly add it. So v net is equal to 0, v net will be equal to v1 plus v2 and that is equal to 0. So from here you will obtain a very important relation between R1 and R2. So KQ by R1 minus K, or you can say K into minus 2Q by R2, that will be equal to 0. So KQ, it will be simply common out, and 1 upon R1 will be equal to 2 upon R2, and from here R2 will be equal to twice R1. This is the relation which you had obtained between R2 and R1. Okay, but you actually need the locus in the coordinates x comma y. Okay, so you have to eliminate this r2 and r1. So how you will be eliminating that? You got the relation between them. So how? Because you want in the format of x and y. So you can relate r1 with x and y very easily by the Pythagoras theorem. So that only I am doing right now. What I will be doing, I will consider r1 square will be equal to x square plus y square, and r2 square will be equal to 6 minus x whole square plus y square. Right? Now, because we know the relation between R1 and R2, R2 is greater, so that's why directly you can consider this as equation 2 or equation 3. So from both these equations, what you will be doing, you will be very easily able to understand, so 6 minus x whole square plus y square will be equal to this. Simply from here you can get the relation as r2 square will be equal to 4r1 square. So r2 square is this, is equal to 4r1 square, and r1 square is x square plus y square. So now you can see that you had obtained an equation actually in or close to this format. So now you have to simply interconvert so that you can get the particular format. So here it should be r. Okay, so let us first break this. So minus 12x plus x square plus y square plus is equal to 4x square plus 4y square. Okay, now this is x square, this is 4x square, so this will be 3x square. When it will go this side, this will also become plus 3y square, and this will be minus 12x, so it will become plus 12x, and when this will go this side, it will be minus 36 equal to 0. Simply take 3 common out, so x square plus, I'm taking this side. Okay, I'm keeping all the x terms together, so this will become 4x, and when you will be keeping this will become minus 12. I'm keeping this separate, and plus y square is equal to 0. So now as you can see, this is not a perfect square. Okay, because you can see it will be like getting factorized. Actually, we need in this particular format, in a proper square format, which we had studied earlier. Okay, I had even taught you a quadratic equation chapter, and there I had told you all the methods of the quadratic equation. Okay, so from there you will be very easily able to approach that in which direction we have to approach. Okay, so this will simply become like I have to make it a square. So x square plus 4x. So from here we will get an idea that what should be the value of b square. So it will be simply 4. Then only it will be possible. So if it is plus 4, then we have to subtract minus 4 also, and this is minus 12 by default. Okay, and plus y square equal to 0. So this is making now a square, so x plus 2 whole square, this will be only y square, and this will be, because there is no any 2y kind of term, so that's why we know that no, the directly the square will not be possible. Okay, so that will be equal to plus 16, and from here x plus y whole square plus y minus 0 whole square will be equal to 4 square. This is actually now in that format which we actually want, and from here it is plus 2, so hence when you compare with that format, hk will be nothing, it will be minus 2 comma 0, and the radius which you will be getting will be 4 meters. Okay, so that will be directly your answer. So there is an option. Yes, 4 meter and center minus 20. So this B option will be directly correct. I'm telling you, this question I had given you in the assignment last year. As it is, this question has came into your examination. So if whosoever has followed the assignment questions given by me, of course they had done this question directly. They had directly ticked this option, and they had simply saved this much time in the actual examination. I hope you are getting that how exactly we are approaching the question, and in the very next video I will be solving some few extra questions based on some applications. Let us see.